Hello, my name is Danny Thompson, and this is a presentation on enterprise system integration with the Internet of Things. Today, the Internet is no longer just for computers and servers. The Internet of Things is a term that has been introduced in recent years to describe objects that communicate via the Internet. Things that are now found on the Internet include sensors, actuators, and many other smart tech. Smartphones, cars, watches, homes, TVs, offices, and hospitals. Smart objects use RFID, or radio frequency identification, which is a way to identify and track devices using radio waves. They also utilize SCM, supply chain management applications, which obtain real-time data from devices or objects, and WSN, or wireless sensor networks. The Internet of Things is moving towards making objects part of the business process in enterprise systems. Two of the major components of the Internet of Things are cloud computing and big data. Radio frequency identification. RFID is a generic term for technologies that use radio waves to automatically identify people or objects. According to the Radio Frequency ID Journal, this technology has been around since the 1970s. However, up until recently, this technology has not been practical and has been way too expensive. With the birth of wireless standards and the growth of radio networks, RFID has become viable again. Also, the demand has made it affordable. Communication standards such as Wi-Fi, Bluetooth, 3G, 4G are used with RFID. RFID applications in sensors and microchips use a wide range of different radio frequencies, such as like ultraviolet and all those other frequencies. Anyway, RFID is a communication standard with the Internet of Things. RFID can use logic controls, and which is coined sometimes as intelligent programs. You can program an RFID object to perform an action automatically. If X happens, then do Y. Cloud computing. The National Institute of Standards and Technology's definition of cloud computing. Cloud computing is a model for enabling ambiguous, convenient, on-demand network access to a shared pool of configurable computing resources, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud computing model promotes availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. Defining the cloud computer and its role in business enterprise can be a research paper in itself. I should know, I already wrote one. The cloud computing complex is one way in which the ITOA uses big data to power applications on smart objects or devices. The 5 characteristics of cloud computing are on-demand service, which is where a consumer can unilaterally provision computing capabilities such as server time, network storage, as needed automatically without requiring human interaction with their service providers. Broad network access capabilities are available through network and accessed through standard mechanisms that promote use of heterogeneous thin or thick client platforms. Resource pooling, the provider's computing resources that are pooled to serve multiple consumers using multi-tenant models with different physical and virtual resources dynamically assigned and reassigned according to the consumer demand. Rapid elasticity capabilities that can be rapidly and elastically provisioned, in some cases automatically, to quickly scale out and rapidly release to quickly scale in. Measured services, cloud systems automatically control and optimize resources used by leveraging a metering capability at some level of abstraction appropriate to those types of services. The three service models of the cloud are Cloud Software as a Service, SaaS, the capability provided to the consumer to use the provider's applications running on the cloud infrastructure. Cloud Platform as a Service, PaaS, the capability provided to the consumer is to deploy onto the cloud infrastructure consumer-created acquired applications created using programming languages, tools supported by the provider. And then you have Cloud Infrastructure as a Service, IaaS. The capability provided to the consumer is to provision processes, storage networks, and other fundamentally computing resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The four deployment models of the cloud are the private cloud. This is a cloud infrastructure is operated solely by the organization. It may be managed by the organization or a third party and may exist on-premise or off-premise. Community cloud is a cloud infrastructure that is shared by several organizations and supports a specific community that has shared concerns. A public cloud is a cloud infrastructure that is made available to the general public or a large industry group and is owned by an organization selling cloud services, like Amazon Web Services, for example. A hybrid cloud is a cloud infrastructure that uses two or more cloud models. Big data. According to a statement on IBM.com, big data is being generated by everything around us at all times. Every digital process and social media exchange produces it. Systems, sensors, and mobile devices transmit it. Big data is arriving from multiple sources at an alarming velocity, volume, and variety. Big data is hosted by a server, and the IoT devices and sensors can get information from the cloud applications embedded within microchips or other technologies on single-board computers. Data can be sent to the servers, used for things such as supply chain management, while other sensors can be used in emergency response systems, collecting data to predict and warn us of natural disasters. In a case study done in Xinjiang, China, they showed that data obtained by integrating IoT and geoinformatics using remote sensors and GIS, which is Information Systems, and GPS, and cloud services, they can help predict floods from melting snow. Wireless sensor networks. The Internet of Things can use sensors in various smart devices to create a network of wireless sensors. In an article found in the International Journal of Distributed Sensor Networks titled An Internet of Things Approach to Managing Smart Services Provided by Wearable Devices, the author discusses how smart devices such as tablets, smartwatches, and smartphones can be utilized to monitor a person's health. And a new emerging technology, the Internet of Things, is wearable devices, such as your smartwatch or a Fitbit. This article goes over the use of the wireless sensor networks and wearable devices using sensors and alarm applications to alert healthcare professionals serving the elderly. In the article, the patient wears a device with a sensor type application that uses a database of information in the patient's chart. The device alarms when something is wrong, such as increased body temperature, elevated blood pressure, decreased heart rate, or O2 stats. All readings are transmitted to a nurse's smartphone or tablet via either the wireless local area network or Bluetooth. Big data and the Internet of Things working towards automating manufacturing in the manufacturing industry. According to an article on the Tech Republic website, Germany is looking at combining the use of big data, the Internet of Things, sensors, and robotics to fully automate manufacturing, sort of like a smart factory. McKinsey and Company describes smart manufacturing as a type of information system through sensors and actuators embedded in physical objects where processes govern themselves, where smart products take corrective action to avoid damages, and where individual parts are automatically replenished. This sounds like something out of a science fiction movie, but with big data guiding the Internet of Things, sensors to know exactly what to make and when to make it and how to make it. According to this article, there are some progressive companies already investing in fully automated manufacturing plants. And summary here, in conclusion, the Internet of Things, cloud computing, and big data are a growing trend in enterprises across the globe. Using technologies such as sensors to create wireless sensor networks with radio frequency identification at the heart of most IoT devices, the Internet is no longer just for your PC and laptop. Devices even as small as an ID badge can access big data, receive logic programs and commands, be tracked and located, even alerting someone there's a patient in need of help, or to help warn us of a pending natural disaster. We're living in a world where automation is king, the future is now, and we are the minds that can make the possible impossible. We have made it where things now work for us.